Assalamualaikum warahmatullahi wabarakatuh. Today we want to present our project title Ergonomic Redesign of Scraper Tool for subject Ergonomic Design BMID 3553. For group member, we have 5 group member. Number 1 is Abdul Razif bin Abdul Rahim. The second one is Muhammad Anas bin Jafridin. The third one is Mira Kuja anak Migi. And then the fourth is Khairul Faiz bin Ahmad Fauzi. And the last one is me, Nur Saiful Afiq bin Rosata.
So, hand tools such as scraper are widely used in industrial construction for tasks like surface cleaning, paint removal and metal scraping. Because these tools are often used manually for a long period and involve repetitive movement, their design greatly affect worker comfort, safety and productivity. Conventional triangular scraper commonly cause discomfort due to poor handle shape, weak grip, unsuitable blade angle and unbalanced weight. Therefore, this project focused on redesigning the triangular scraper with improved ergonomic features to reduce physical strain, lower posture-related risks, and enhance overall work performance in construction environment. We focus for these projects is first is to improve the handle design by incorporating an ergonomic shape and non-slip grip to reduce hand fatigue during prolonged use. Second, to redesign the handle size and diameter to allow a more natural hand posture and better grip control. Third, we to enhance overall tools usability and safety for industrial construction application. So the last one, to increase task efficiency by provide easy handling and safety features for better operational accuracy.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Faiz bin Ahmad Fauzi. So today I will talk about methodology. So the first step is problem identification. So we need to identify the issue with conventional scraper. So the problem is manual surface preparation is in industrial painting remains a high risk activity due to the reliance on conventional linear handle scraper, while current professional models like the Tajima L type offer improved material. The fundamental design failed to address 3 critical ergonomic hazards. So the problem is fatigue, restraint, poor grip and safety risk. The second step is user requirement study. So user requirement study is to understand needs of user in industrial and construction workers. So we have make market survey. So from that market survey, we can focus on comfort, safety and usability. So the third one is ergonomic analysis. So for an ergonomic analysis, we use hand anthropometric measurement data from previous lab and online research. And then from that data, we decide a suitable hand size, shape and dimension. So from all that data, we can ensure that design fits most user and suitable for industrial and construction worker. Then the next one is concept development. For the concept to redesign this hand tool, we create sketches and several design concepts that focus on power grip optimization, integrated finger guards and a soft touch grip on a curved handle by transitioning from a straight cylindrical shaft to an automatically curved geometry. The tool allows the user to maintain a neutral wrist alignment, effectively shifting the mechanical load from the small tendons of the wrist to the largest muscle group of the arm and shoulder. So the next one is feature improvement. The first step is reducing RSI, which is repetitive stress injury, and then improving grip design and solving excessive force requirements. So for evaluation planning, you need to plan and compare ergonomic scraper with conventional scraper and focus on comfort, safety and usability. You can see from here, this is our conventional scraper and ergonomic scraper that we improve from the conventional scraper. One is market survey. The first question is frequency of conventional scraper usage during daily working hours. Based on the first pie chart, the majority of respondents use the conventional scraper at a relative balanced frequency, which is 30% of respondents rarely use the tool, 30% use it occasional, and 30% use it frequently during daily working hours. Only 10% of respondents use the scraper very frequently. This indicates that the usage level of the conventional scraper is generally moderate and evenly distributed among respondents.
Alright, I will continue the presentation. I'm the presenter, Muhammad Anas bin Jafridin, and I will present the market survey for the question: average duration of conventional scraper usage per working session. The second pie chart shows that most respondents, 56.7%, use the conventional scraper for less than 15 minutes per working session. Meanwhile, 16.7% of respondents use it for 30 minutes, and 13.3% respectively use it for 30 to 60 minutes and more than 60 minutes. This suggests that the conventional scraper is predominantly used for short duration in each working session. Next, for the third question, comfort level of the scraper handle during use. Based on the first pie chart, more than half of the respondents, 53.3%, rate the comfort of the scraper handle as moderate. Meanwhile, 30% of respondents felt that the handle was uncomfortable. A smaller proportion indicate positive comfort level, with 10% stating that the handle was comfortable and 3.3% rating it as very comfortable. Additionally, 3.3% of respondents report that the handle was very uncomfortable. Overall, the results suggest that while most users perceive the handle comfort as average, a notable portion experience discomfort during use. Go for next slide. Suitability of scraper handle size and shape with hand size. According to the second pie chart, the majority of respondents, 60%, perceive the size and shape of the scraper handle as neutral, indicating neither strong satisfaction nor dissatisfaction. Furthermore, 23.3% of respondents felt that the handle was not suitable for their hand size. On the positive side, 10% of respondents found the handle suitable and 3.3% considered it very suitable. Another 3.3% rate it as very unsuitable. The findings indicate that while the handle design is generally acceptable, improvement could be made to better accommodate users' hand size and shape. Okay, for the body part most frequently experiencing discomfort after using the scraper. Based on the bar chart, the wrist is the body part most frequently reported to experience discomfort
after using the scraper, with 70% indicating discomfort in this area. This is followed by the arm, reported by 40%, and the shoulder, reported by 23.3%. A smaller number of respondents, 6.7%, experienced discomfort in the back, while no responder report experiencing no discomfort. This result indicates that scraper users predominantly affect the upper limb, particularly the wrist and arm. And then for the force level required to use the conventional scraper, according to the pie chart, nearly half of the respondents, 46.7%, perceived the force required to use the conventional scraper as moderate. Meanwhile, 40% of respondents felt that the required force was high, and 10% reported that it was too high. Only a small proportion, 3.3%, considered the required force to be low, and none rate it as very low. Overall, this suggests that a considerable number of users perceive the scraper as requiring a relatively high level of force, which may contribute to physical discomfort during use.
Okay, I will continue our market survey. So next, for analysis of wrist movement frequency, based on the pie chart involving 30 respondents, the data examines whether using a scraper cause awkward or repetitive wrist movement. The majority of participants, accounting for 53.3%, reported that they experience such movement sometimes. However, a significant portion of the group feel these strains more frequently, with 26.7% responding often and 13.3% responding very often. Okay, next market survey is analysis of user fatigue levels. This pie chart illustrates the level of fatigue experienced by the 30 respondents after using a conventional scraper. Exactly half of the respondents categorized their exhaustion as moderate. More concerningly, a combined 43.3% of users reported high level of fatigue, with 23.3% feeling very tired and 20% feeling tired. Okay, next market survey is analysis of long-term pain or injury. This pie chart details response to the question of whether users have ever experienced pain or injury due to long-term scraper use. Out of 30 response, a majority of 63.3% state they have not experienced such issues. However, a significant total of 36.7% reported some form of physical impact. This includes 23.3% who gave a general, that is yes, response, while the remaining respondents provided specific details such as shoulder pain, pain occurring almost every week, and specific pain in the wrist area. Okay, next for question of analysis of the need for ergonomic improvement. This pie chart addresses user opinions on whether the conventional scraper needs to be improved from an ergonomic design perspective. The data shows an overwhelming consensus in favor of redesigning the tool. Nearly 3/4 of the respondents, 73.3%, believe that improvements are very necessary, while 23.3% state they are necessary. Combined, 96.6% of 30 respondents agree that the current design is inadequate and requires ergonomic intervention.
Okay, so next is for result. what we get for the features for this redesigning scraper. So first one is handle thickness. The dimension is 30 mm. The handle length is 110 mm, and then the finger groove on the handle 16 mm for the average that have 4. Blade thickness 2 mm, blade angle on the handle 50 degree, and tool length overall is 160 mm. So the second, we compare between the conventional 4-inch scraper brand Tajima and our ergonomic redesign. So for the handle for scraper Tajima is average 100 mm to 110 mm. For our is 110 mm. And then the handle diameter, it's cylindrical 30 mm, and our have some elliptical which 38 mm to 42 mm. For the neck angle, if you can see that conventional 4-inch scraper is straight line, no degree, and then for our is 50 degree offset bend. For the grip shape, uniform oval and cylindrical, and our is contoured palm swell. Then blade width 100 mm. Also our ergonomic redesign is also 100 mm. So for the finger guard, as you can see and know that conventional 4-inch scraper have none of finger guard, but our we consume to our redesign with integrated flare which have 55 mm width. So the next one is we test our product redesign with mannequin and mannequin Katia. So the first one we use 5th percentile man Japanese. We can see that the mannequin can hold perfectly our shape with the dimension that we do. So the second is the 50th percentile man Japanese, also can hold our shape perfectly as we plan on the project objective. So the next one is for design or concept. For our design, first one we have a features that is 15 degree angle handle. So in simulation, this angle allow the scraper blade to remain flush against a vertical or horizontal surface while the user wrist remain in a neutral handshake position. So the second one is ergonomic power grip control. The tool reduce hotspot of the pressure on the palm, allowing the user to exert high force with significantly less muscle fatigue. So the third one is integrated finger guard and pommel. This allow the user to drive the tool using their shoulder and core rather than just their grip strength. So next one is multi-materials of grip. A micro texture surface on ensure a secure grip even in oily or sweaty industrial environment. So it can reducing the squeeze force required by the user. So the last one is high carbon stainless steel blade. The sharp blade requires significantly less downward force from the user, reducing the strain on the shoulder and elbow muscle during thick pen removal.
Okay, next for discussion. Number one is implementing anthropometric dimension. First one for handle diameter, that is power grip optimization. The CAD model utilize an elliptical diameter of 40 mm. This specific measurement allows for maximum torque and force transfer from the forearm while minimizing the squeeze force required by the user. Then the second one is handle length, pressure distribution. We extended the handle to 110 mm to ensure it clears the palm breadth of the 95 percentile. This avoids contact stress on the ulnar nerve, a common failure in the shorter Tajima model that cause hand numbness. And then the third one is the 15-degree offset. The 3D model implement a 15-degree bend in the neck. This is the critical design solution that allows the wrist to remain in a neutral handshake position, even when scraping at floor or ceiling heights. And then for overcoming redesign challenge, we have 4. That is, we reducing repetitive stress injuries, RSI, through posture. And the second one is minimizing force requirements, and then enhancing grip security, and then lastly is managing impact shock.
This enhancement reduce physical strain, improve comfort, and promote safer walking posture. Also, to compare to the original design, the revised scraper shows lower posture risk, better usability, and improved work efficiency. Overall, the ergonomic redesign meets the learning objective of considering human capabilities and limitations while supporting safer, more productive, and sustainable industry construction practices. For conclusion, this project demonstrates the effective application of ergonomic principle in designing a triangular shaped tool for industrial construction use. It is conventional scraper design were found to cause ergonomic issues such as poor grip, high force demand, awkward wrist posture, and increased risk of musculoskeletal disorder. The improved design was developed through observation, ruler, ergonomic assessment, and redesign using CATIA software. This enhancement reduce physical strain, improve comfort, and promote safer walking posture. Also, to compare to the original design, the revised scraper shows lower posture risk, better usability, and improved work efficiency. Overall, the ergonomic redesign meets the learning objective of considering human capabilities and limitations while supporting safer, more productive, and sustainable industry construction practices.